Hello, in our last video we were talking about the light-dependent reaction of photosynthesis. Today we're going to talk about the light-independent reaction, also known as the Calvin cycle. But I wanted to pick up from where we left off on light-dependent reactions. In the light-dependent reactions, we created a molecule called NADP+, or I affectionately called NADPHA. We also made a molecule called, or made molecules called ATP, adenosine triphosphate. Both of these are energy molecules. Both of these are going to temporarily carry energy to the stroma where we are going to complete the process of photosynthesis. The whole goal of photosynthesis is to create a carbohydrate from sunlight energy, so we can save, so these organisms can save that sunlight energy. And again, we're talking about organisms like plants, photosynthetic bacteria, algae. So let's talk about the light-independent reaction. It's also called the Calvin cycle. So the reason why it's called the Calvin cycle is because it is literally a cycle. What we start with is what we end with. So when we start the Calvin cycle, we're actually going to add in carbon dioxide. So we're going to add in CO2, and that CO2 comes from the air. And again, we're talking about the light independent reactions. So we are in the stroma. So this is the stroma. So we are in the chloroplast and we are outside the thylakoid. In the thylakoid, we had several molecules that were made and those two molecules are actually going to be used now in this process. So CO2 is added to this process, and when we add those CO2, we get 12 3-carbon molecules. And in order to continue this process, we have to add 12 ATP. Those 12 ATP came from the light-dependent reaction. And we're going to actually put the energy of those ATP into this process. And when we do that, we get 12 ADP that can then go back to the light-dependent reaction and pick up more light energy. We're also going to have 12 NADPH, NADPHA, as we were calling it in the other video. And they're going to drop off their energy in this molecular reaction. And then the NADP plus is again going to go back and pick up more electrons and hydrogens from the light-dependent reaction. When we do this, we still have 12 3-carbon molecules. Those 12 3-carbon molecules just now have more energy. And what happens is we now have molecules that have enough energy. We can remove 2 3-carbon molecules, and those 2 3-carbon molecules can then combine and become one 6-carbon molecule. And this is these are sugars and other compounds. The type of sugar that we're interested in making is called glucose. And you can see that we've got what we need now because we need 6 carbons, because it's C6H12O6. And that is enough to make that molecule. Well, when this happens, we end up over here with 10 3-carbon molecules. And what we need to do is we need to regenerate what we started with, and that takes energy to change around these molecules. So we're going to use 6 more ATP. And when those ATP are used, they become ADP, and that ADP can then go off and go back to the light-dependent reaction and pick up more energy. When we do this, we now have 6 molecules, but each molecule has 1, 2, 3, 4, 5 carbons. And those 6 5-carbon molecules will again combine with CO2. And that CO2 will then make 12. And actually there are 6 CO2 that are added to this process overall. And you can see why we need to add 6, because we need 6 carbons to go into the cycle, so that when we get to this point, we can pull 6 carbons out of this cycle. And this is the light independent reactions. So the goal is to take carbon dioxide from the atmosphere and fix it into a molecule that will store large amounts of energy for a long period of time. And that energy comes from the ATP that was made in the light-dependent reaction and the NADPH that was also made in the light-dependent reactions. And this will give you the general information that you need for the light-independent reactions for class. If you have any questions, let me know.